Welcome to qnawire.
Hi. So in the problem, it's given that uh, the cathode ray tube oscilloscopes have parallel plates inside them to deflect the electrons. So cathode ray tubes were used in older televisions. So let us draw the parallel plates. So these are square plates with the area A, which we need to calculate, and some plate separation D. And we are required to find the capacitance of this parallel plate capacitor, or in other words, the capacitance of the oscilloscope itself. So let us write what is given to us. So we are being provided with, since these are square plates, the length of each side of the square, let's say small a, is given to be 3 centimeters. If I want to write in terms of meters, it's going to be 3 times 10 raised to negative 2 meters, and the distance between the square plates is given to be 5 millimeters, or in terms of meters, it's going to be 5 times 10 raised to negative 3 meters. Uh, and we know that the capacitance of parallel plate capacitors with air or vacuum in between them uh, equals C equals epsilon naught, which is electric permittivity, times area A divided by distance t. So this is the capacitance of parallel plate capacitors, which we are required to find here. So with the information given to us, uh, we can find the capacitance, but before finding that, we need to find the area of each plate. So area of each plate, since these are square plates, so it's going to be square of each side, the length of each side is given to be 3 times 10 raised to negative 2 meters. So 3 times 10 raised to negative 2 whole square in terms of meters square. And this value is going to be, so we have 3 square as 9 times 10 raised to negative 4 meters square. So this is the area of the plate in terms of meters. Okay, so let's substitute these values. So we have the capacitance C equals epsilon naught times area over D. As we know, your epsilon naught is 8.85 times 10 raised to negative 12 times the area, which we calculated to be 9 times 10 raised to negative 4 divided by the distance in meters, which equals 5 times 10 raised to negative 3. And if you calculate this value, it's going to be equal to 1.59 times 10 raised to negative 12 farad. So this is the capacitance of parallel plates, which is present inside the oscilloscope, or in other terms, this is the capacitance of the cathode ray tube. As you can see from the formula of the capacitance, that the capacitance C is directly proportional to area A. That means C increases with area A and C decreases with the increase of the plate separation. Thank you very much.